Hello, everybody. Today we're gonna do, a quick little review for 6162 quiz that's tomorrow. I don't really have much to say. I think that 6162 is a very abstractional unit. It's just like the start of something a lot more different from what we typically learn. But I think that once you kind of find the way to see the formula inside of it all, I think it gets pretty rudimentary and simple. And so that's just kind of going to be my goal today of just showing you guys the pattern in it all and kind of figuring that out. So first thing I want to start with is Reiman sums. Reiman, sums. And I just want to say that there's a three columns. You have 1 left, 2 right, and 3 the midpoint. And there's not really that much. The difference is, like, let's say you have a question that asks you, create a left Riemann left Riemann. I don't know why it's called Riemann. Create a what? Left Reiman. And so all you're doing, let's say you have and it says in four partitions with X chords, let's just say 1 through 5. Let's just say that. And so if you're doing a left Riemann sum, then all you're going to do is you're going to say, well, you have 1, let's just say that, what is that? 2, 3, 4, 5. So left Riemann sum, you're going to take, I think it should be 4 actually, whatever. Just say 1 through 4. And so, oh no, that was right. Never mind. But yeah, let's just say your left Riemann sum should start on the very first part, if that makes any sense. So I want my left Riemann sum to be to start at the f of x of 1. So I'm just going to use this example, equals f of 1. If it was a right Riemann sum, okay, then it ends at f of 4. If it was a right Riemann sum, you would want it to start at f of 2 and end at f of 5. So I hope you can see the difference there. Left, you're starting it at the very first number, like the very first number of the x coordinates, and you're ending it 1 before. But on the right Riemann sum, you're starting it on the right, you're starting on 1 plus the first number, then ending on the very last x value. Midpoint is kind of, it's not really different. It would just be like, I don't think it works very well for this, but let's just say you had you had something like, you had a they want a midpoint Riemann sum from midpoint Riemann sum from, let's just say, I don't remember what the thing was, but I think let's just do 1 through 5 with 2 partitions. And I think, I'm going to look at the homework. I think it is something along those lines. But essentially what you're doing is you're just doing like the midpoint of it all. So like let's just say like midpoint subdivision. It's like, so you do 1, let's do the number line. 1, 2, 3, 4, 5. So your midpoint sum would be 1 to 3, and then we can do 5 to 3. So you see how that's kind of different? It's like the midpoint. I don't really know. It really only works when you have like what's it called? Like you'll see in specific points, like I just say don't worry about it. Don't because the example they give in the homework is C. It's like 3 subdivisions to estimate the division over 0 to 3, and it's already partitioned up into 6. So it's like you're dividing the number. Really, don't worry. I just say worry more about partition, like the amount of partitions, because you can only do like let's go back to the example of like, say this was like 4 partitions. You couldn't really do a midpoint sum, you know what I mean? Like you kind of have to like it wouldn't work. So don't worry about that. If you see it, it should just kind of be like common sense intuitiveness. So that's what I want to talk about, Reiman sums. And yeah, I think the next thing, I mean, that was the most important thing about 6-1, but we can also talk about 6-2, which was, I believe, about translating integrals into Reiman sums. We can also talk about trapezoid partitions. Trapezoid partitions. Trapezoid. Reiman sum is literally just the f of like 1 plus f of 2 divided by 2, and then you do that for however many Reiman sums. So like if it's a left trapezoidal Reiman sum, then you can just kind of go back to this idea here of like you would do f of 1, you would start at f of 1 plus f of 2 divided by 2 all the way to like f of 3 plus f of 4 divided by 2, whereas if you had a right Reiman sum, you would start at f of 2 plus f of 3 divided by 2, and then you would go all the way towards f of 4 plus f of 5 divided by 2. So that's all you have to worry about trapezoidal things. It's not something, I don't think that's a big deal. The next big thing is translating integrals into a Reiman sum. I mean, that is pretty easy. Please remember, I mean, if you don't remember, just look at your packet. But it shows you kind of what you need to remember. The formula is kind of like, I'll break it down. To write it, you want to change, like you're going to have an equation that's like this. It's going to look like, let's just say like 5, 4, and I'll give the example of like 3x squared minus 1. And it's going to ask you like, how can you change this into a Reiman sum? The first thing you're going to want to do is you're going to do this thing, which is like, it's the n and then k equals 1. So this should be goes for all equations. the next thing you want to do is you kind of want to figure out, there's two steps. The first step I want to do, because what you're going to want to translate this equation into is not this, but you want to, first thing you want to do is kind of find, I'll just say, find like this kind of funny looking thing right here. And so how you would do that is all you have to do is the B. So this is equals B, this equals A. And so how you do this is A minus B over N. And N is just like nothing. Like use N stays the same. And so let's just do it, tie this back to this example. The, what's it called? The pyramid of X for this one equals 1 over N. So that's step one. The second step that I want to do is I want to find, what are we substituting? Substitution for X. And so that's pretty simple. All that is you're going to take B plus, oh, not B. This equals A plus K. So literally, and the K always stays the same. Always stays K. And then you're going to multiply K times this thing. So this goes into here. So for this equation, what would this be? Step two, that would just be, what's it called? It would be A is this. So A is 5 plus K times whatever this is. And so we know that whatever the pyramid X thing is. So it's 1 over N. And so now the third step is put it all together. So all we need to do is we need to substitute the X. So we have what's it called? N over K. And then we're going to have our 3, and we're going to substitute the X for what we just said here, the A and the K. Sorry. The A plus K times our pyramid X. So A was 5 plus K of 1 over N. And then that's that. And then we just plug in the 1. So minus 1. And the last step is to add the pyramid X at the very end of our equation, which we said right here was 1 over N. So that's pretty simple. I think the last thing you need to remember how to do is how do you kind of do it in the opposite way. So let's just do like, let me get some water real quick. Excuse me. Not very professional of me, but happens. All you gotta do is, what's it called? You just gotta think of it backwards. So let's go step by step. You know, remember how we said step 1 was to find pyramid of X. So our first step we want to do is find the goal when you're working backwards. Goal is find A and B, because that's what you want to. Once you can do that, you can pretty much like because you can tell what is being substituted for x. And so I'll give the example of like, let's look, what's an example? Because you can tell based on the fact that it's a plus k of pyramid of x, you can tell like if you're doing like, let's just say like your original equation is like 2x. You know what your thing should look like? It should look like 2 parentheses something, you know, whatever. Let's say 5 plus k 1 over n. That's how you know, because there's this like extra little parentheses kind of separating it. And even if like the a was 0, it would still be 2 parentheses, which separates k 1 over n. So that's not that hard. You just look out for this little parenthesis right here that kind of, what's it called, separates it. But now, finding a and b. A and b is not totally that hard. Like I said, to find a, all you have to do is very simple. If you know that the value that you're substituting x for of x is just this, then you know, like you're just given the a. So let's like say like 2, I'll give you an example from one of the packet equations. 2 times k over n plus 3. Well, if it's a, let's just look. Like if you draw this back to this, k and n, this, okay, I'll switch the colors. If this is like, we're gonna say this is like the term for the k and n, you can see that's right here. And then you can see that the a value is right here. So therefore you have your a. So a in this equation equals 3. Let's just say at the, now you want to find b. How are we going to find b? And so to find b, all you really have to do is say, let's say the equation is 2 times k over n plus 3, and then you have, what's it called, times 1 over n. Well, you remember that this equals the x thing, the pyramid x. And so pyramid of x is just a minus b over n. So let's just say a minus b equals like x. And x is going to be the thing that you find. So this right here is kind of, well, no, this is equal to this. So let's just say a, which was, well, 3 minus b needs to equal 1. So how do you do that? It's literally the simplest algebra, I think, in human history. And so that's just b equals 2. So hopefully that makes sense between all my coughing. But yeah, that's really all that's important. Everything else should be pretty simple. Yeah, thank you. Hopefully this helps out.